We have now worked with exponents from the set of whole numbers, that is, positive numbers and zero. Sometimes, however, we come across exponents of the negative nature also. We would naturally expect negative exponents to be tied to the sign of the product, but that would be wrong. Recall that a square of a negative number produces a positive number. But what if we have a negative square? 2 to the negative 2. How do we mathematically identify the nature of a negative exponent? As it would turn out, negative exponents are kind of unexpected in their execution. It isn't just a coincidence that we chose first to study the product rule, then the rule of zeros. The rule of negative exponents that we'll explore here actually is a great mediator between the product rule and the next rule to come in the next lesson. With that said, we'll take advantage of the product rule once again and use it to help us to write a definition for the rule of negative exponents. Let's look at the term 2 to the negative 2. This does not mean 2 times negative 2. It does not mean that, because 2 and negative 2 are different bases. We cannot express 2 times negative 2 as an exponent anyway. Remember, exponents represent repeated multiplication. Let's look at how 2 to the negative 2 reacts to another number in a product rule. Let's use 2 squared times 2 to the negative 2. Using the product rule, we have 2 to the 2 plus a negative 2, which equals 2 to the 2 minus 2. This becomes 2 to the 0th power, and this we know equals 1. What just happened here? We ended up with the zero rule of exponents. At this point, we can make a logical assumption as to what 2 to the negative 2 is equal to by asking ourselves, what number times another number becomes 1? That's an easy question. This involves the inverse property of multiplication. Remember that the inverse property of multiplication is actually the definition of division. And we know that any number divided by itself becomes 1. This means that 2 to the negative 2 is the inverse of 2 squared. Here is the definition for negative exponents. For all natural numbers n and all non-zero real numbers a to the negative n equals 1 over a to the n. For this property to work, n must be a natural number. Remember that the set of natural numbers are all positive numbers. But notice that we are taking the negative of n. As long as n is a natural number, that is, any whole number greater than 0, the sign will take the negative of the natural number being used for n. So any positive natural number n will work in this definition. All real numbers are guaranteed to work with negative exponents. Let's do a few examples. Number 1, 5 to the negative 3 power. Our first example illustrates the simplicity of the definition. We first inverse the base and then cube the result, giving us 1 over 125. Number 2, 1 over 6 to the negative 2. Here we have a rational number with a negative exponent. By taking the inverse of the denominator, we change the number into a whole number that we can then square, giving us 36. Number 3, 3 times x to the negative 2 power. Remember our exponent's range. Our exponent is only affecting the variable, leaving the coefficient unaffected. This gives us 3 over x squared. Number 4, 2 to the negative 4 power times x. As with the previous example, our exponent's range is leaving the variable unaffected. This becomes x over 2 to the 4th power, which becomes x over 16. Number 5, negative y to the negative 2 power. Normally, when you square a negative number, you end up with a positive product. But our sign here is out of the range of the exponent. So this becomes negative 1 over y squared. Number 6, negative 5z all raised to the negative 2 power. Just like with other exponents, if our expression is in parentheses, then the exponent will affect the whole thing. So we have 1 over negative 5z all squared. Notice that I brought the negative down with the 5 and didn't leave it with the 1 in the numerator. Everything in the parentheses stays in the parentheses until I simplify the exponent. This now becomes 1 over 25z squared. Number 7, 2 to the negative 1 plus 3 to the negative 1. Here we have two terms with negative exponents being added. First, we get the inverses to get 1 over 2 plus 1 over 3. If you don't remember your rule for adding exponents, it's multiply the denominators into both parts of the opposing fraction. So this becomes 1 times 3 over 2 times 3 plus 1 times 2 over 3 times 2. This becomes 3 over 6 plus 2 over 6. We can now add across because the denominators are the same. We are left with 5 over 6. Number 8, we have 1 over 5 to the negative 2 power times 5 to the negative 1 power. This expression contains two negative exponents, one with a whole number, the other with a fraction. We apply our rule of negative exponents to get 5 squared times 1 over 5. This becomes 25 times 1 over 5. You should recognize that a number multiplied by an inverse is a type of division. So we have 25 divided by 5, which becomes 5.